So lesson 58 is entitled Completing the Square. Now this is something that we've never done before. And what it is a technique for solving quadratic equations. So the motivation for this is, suppose we had like a really simple quadratic equation like, x squared equals 9. Now normally when we think about solving quadratic equations, we think, oh, we have to factor and use the zero product property, but here there's nothing really to factor. We can just say, okay, well, what number would I have to square to get 9? Okay, and you naturally think of the number 3, but don't ever forget that there are two numbers that you can square to get the number 9. You could square 3, or you could square -3. Both of those would give you. So when you solve this, you say, oh, I would take the square root of this, both sides. So I take the square root of x squared, I get x. When I take the square root, there's two square roots. There's the positive and the negative version of the square root. Okay. So we've got two answers, plus or minus 3. Okay, so the idea behind completing the square is to try to get an equation that's going to be easy to solve by just taking the square root of both sides. So let's do one that's slightly more difficult. Let's say that we had something like, x, plus 2x plus 1 equals 16. Okay. So we have this equation, and at first it seems like, oh, it's kind of difficult. Maybe we should subtract everything from and move it to one side, set it equal to 0, and try to factor it. Well, if we did that, we would find it was very difficult to factor with having a negative. Well, maybe not very difficult to factor, but it might be harder to factor than what we see here. I can already factor this, and I see that this is actually a perfect square. It factors into x plus 1 times x plus 1. Okay, or another way to write that is x plus 1 squared equals 16. And now, really, my equation is in basically the same form as I had up here. And I can just take the square root of both sides. So when I take the square root of the left, I'll have x plus 1. And then when I take square root of the right, don't forget to always remember there are two square roots to every number. So it could be positive or -4 as the square root of 16. Okay. And so now I know that x plus 1 is either 4 or it's -4. So I should split this up into two equations. X plus 1 is either 4 or x plus 1 is -4, and then solve them individually. So if I subtract 1 from both sides here, I'll get x equals 3. If I subtract 1 from both sides here, I'll get x equals -5. Okay, so those would be my two solutions. Okay, so far we haven't actually done completing the square. We're just motivating. Okay, so completing the square is a technique that says, hey, if I could get a perfect square on this side so that I could factor it, it would be really easy to solve the equation. Now, I don't always have a perfect square, perhaps, but I can force myself to have a perfect square, and that's the idea behind completing the square. So let's look at the concept of what's called completing the square. Okay, so suppose I have an equation like this: x squared minus 4x minus 96 equals 0. And maybe I say, that's hard to factor. I don't know the factors of 96. Okay, or perhaps I can't factor it. So in completing the square, I'm not going to try to factor what I have. I'm going to take the constant and I'm going to move it on the other side. So I'll leave the x squared minus 4x alone over here. I'll leave myself a little space, and then I'm going to add the 96 to both sides. Okay, so we get rid of it on the left, and it comes over on the right. Okay. And now, on this side, I'm going to ask myself, well, what would I have to add here so that the resulting trinomial would be a perfect square? Then if I add that number here, and then I add it to the other side as well, then I can factor this, okay, into a perfect square and get an equation that looks something like that. Okay, so if I just add the right value here to force it to be a perfect square, then I can factor it into a perfect square and everything will be great. Okay, well, what would I have to add? Well, you can always take the coefficient that's in front of the x, in this case it's -4, divide that by 2, so half of -4 is -2, and if I add that -2 squared to both sides, okay, then I've just added the same thing to both sides. Why is that helpful? Now, because this factors into x minus 2 squared. Okay, -2 squared is really 4, right? So if you were to multiply this out, you would get x squared, and then you would get, remember, you would have to double the product of x and -2. So double -2x, that's -4x, and then -2 times -2 is 4. Okay. So this, x minus 2 squared is x squared minus 4x plus 4. Okay. So I've added this 4 in the form of -2 squared, okay, to perfectly what we call, this is the act of completing the square. I've added that -2 squared, and that is the thing, the key to make this into a perfect square so that it can be factored into x minus 2 quantity squared. Okay, now what happens to the other side? Well, now I'm going to have 96 plus 4, that's 100. Okay, and now that equation isn't too hard to solve. I just take the square root of both sides. So I get x minus 2 here, and I get plus or minus 10 on the right. Don't forget your plus or minus. So I've got that x minus 2 is 10, or I have that x minus 2 is -10. So this will give me x is 12. And this one will give me x is -8. Okay. Now you could have gotten those solutions by factoring this one. These ones with integer solutions, you can always get them by factoring. But sometimes it's not obvious to see what the factors that you should use are, or if you just have trouble factoring. Okay. Completing the square will always work. Okay, let's try, now that you got the idea a little bit, let's try another one of those. So let's say we had x squared minus 8x plus 20 equals 5. So again, okay, the technique is to say, well, I could, move this over and then try to factor it, or I could just move all of the constants to the other side and then complete the square and then take the square root of both sides. So that's what we're going to do. All right, so I'm going to subtract 20 from both sides to get x squared minus 8x. Leave myself some space so I can complete the square. And when I subtract 20 over here, I'll get -15. Okay. So what would I have to add here to complete the square? Well, I'm always going to add half of the x coefficient. So half of -8 is -4, and then square that. So I'm going to add -4 squared to both sides. Okay. And I like to write it that way because if you write it that, like if you just write plus 16 plus 16, that's correct. But the thing is, when you want to go to factor it, okay, if you want to factor it really quickly, you can just put x, and whatever you put in the parentheses goes right here, and you don't even have to think about it. Okay, you don't have to think about, wait, should that be positive? Should it be negative? Okay, whatever you put in the parentheses is automatically going to go there. So it's just easy to factor. That's why I like to write it that way. Okay, and now I have -4 squared is 16. 16 minus 15 is 1. I'll take the square root of both sides, and I'll get x minus 4 is plus or minus 1. So that means x minus 4 is 1, or x minus 4 is -1. Adding 4 to both sides here gives me x is 5. Adding 4 both sides here gives me x is 3. Okay. Alright, so that is the general technique of completing the square. Okay. So if we were to write steps, okay, for completing the square, Okay. The very first thing you need to do is make sure the leading coefficient is 1. Okay, now none of the steps afterwards will work if the leading coefficient isn't 1. So far in all of our examples, our leading coefficient was 1. It was 1. Okay, we're about to do one where it isn't 1, and it'll make a difference. Okay, so that's the first thing to do, is make sure the leading coefficient is 1. Okay, and then move all the constants to one side of equation. Okay, and so here we moved the 96, the constant, to the other side of the equation. Here we started out with the constants on both sides of the equation, but we made sure they were both on the same side of the equation. Okay, and maybe we could say move all constants to one side of equation and variable terms to other. Okay, so the constant should be on one side, all the variables on the other side. Okay, and then we're going to complete the square. By adding 1/2 the coefficient of x squared, okay, to both sides. Okay, then you're going to factor the perfect square and simplify the constants. You'll take the square root of both sides. And it's very important, don't forget the plus or minus. Okay. And then write two equations to solve for x, or whatever your variable happens to be. Alright, so if we had to write out the steps, that's kind of what they would look like. Alright. So, let's go through that process with this problem. All right, we've got 5n squared plus 20n plus 10 equals -5. All right, so the first thing, are we sure that the leading coefficient is 1? Well, no, I've got a leading coefficient of 5. Okay, I need that to be 1. So how am I going to turn that into a 1? Well, I would have to divide this by 5. If I divide that by 5, I have to divide everything by 5. So divide everything by 5. And then we'll get n squared plus 4n plus 2 equals -1. Alright, my leading coefficient is 1. That's good. Alright, next. Are all of my constants on one side of the equation and all my variable terms on the other? No, so I've got to make sure that that happens. So I've got to subtract this 2 from both sides. So I have n squared plus 4n on the left, and on the right I'm going to have -3. Alright, now all of my constants are on one side and all my variable terms on the other side. Alright, next I need to complete the square by adding half the coefficient of x squared to both sides. So half the coefficient of x, or in this case n, whatever your variable is. I just used x here as a general. But okay, so half of +4 is +2, so I'm going to add +2 squared to both sides. Okay, so I completed the square, and now I'm going to factor the perfect square and simplify the constants. Alright, so it's easy to factor because I'm just going to write n and then whatever I put in parentheses squared. And here I've got -3 plus 4, which is 1. Alright, so I factored. Now I'm going to take the square root of both sides, and of course I'm not going to forget the plus or minus. So I'll get n plus 2 is plus or minus 1. And then I'll write two equations and solve for my variable. In this case, it's mn instead of x. So I'll write my n plus 1 equals the positive 1, and the n plus 2 equals the negative 1. So if I subtract 2 from both sides here, I'll get n as negative 1. And if I subtract 2 from both sides here, I'll get n as negative 3. Okay. So that is the process of completing the square. Now, so far, all of the equations that we've looked at are examples of, if we're good at factoring, we could have figured out the solutions to them by factoring. The next example is actually from your book that I want to look at. So this is on page 416, and we're going to look at problem D here. So solve the x squared plus 26x minus 2 equals 0 by completing the square. Okay, so that's where I'm getting this problem from. Oh, sorry, my book almost fell off. Okay, so let me write that one down for us. This was problem D. So we had x squared plus 26x minus 2 equals 0. Now this one we're not going to factor this. Okay, the other ones we probably could have factored. This one we're not going to factor it. Okay, and so we all follow the process. Yay, the leading coefficient is already 1. All right, now we're going to move all the constants to the other side. So x squared plus 26x. I like to just leave room for completing the square so I don't have to recopy the problem on another line when I get to step 3. All right, now I have to add the same thing to both sides to complete the square. So I'm going to take half the x coefficient, which is 13 squared. So I'm going to add 13 squared to both sides. Okay. And so I'll be able to factor this. This will be x plus 13 squared. And here I get 169 plus 2 is 171. Okay, now I take the square root of both sides, so I get x plus 13 is plus or minus whatever the square root of 171 is. Now that doesn't have a perfect square, but I can see since 7, 8, 9, since it's divisible by, since the digits add up to 9, it's divisible by 9. So let's see, it's 9 times 9 goes into 17 once with 8 left. 81 goes into 81 9 times. That's prime, but this is 3 times 3. Okay, so this is plus or minus 3 square root of 19. Okay, so we're going to write our two equations, that x plus 13 equals the positive 3 square root of 19, and x plus 13 equals negative 3 square root of 19. Those are the two square roots of 171. Okay, and then if we subtract 13 from both sides, we get x equals negative 13 plus 3 square root of 19 for the first answer. And if we subtract 13 from both sides over here, we get x equals negative 13 minus 3 square root of 19. Okay. So you can write those two separate answers that way, or the other thing that you can do as well is you could have gone from this x plus 13 equals plus or minus 3 square root of 19, and when you see it's a number like this, like an irrational number like this, and you're not going to be able to combine them, you can, rather than separating it into two, you can subtract 13 from both sides and put x equals negative 13 plus or minus 3 square root of 19. So this means, this one, if we take the top path, you get negative 13 plus this 3 square root of 19, this answer. If you take the bottom path, you get negative 13 minus 3 square root of 13, this answer. But this is just the shorthand form to write it. And if you were to use the quadratic formula to find the solution, it would end up looking like this. Okay. So you might just want to write your answers like that. Either one of these, either one of these is fine. You can write them both out individually or shorthand it. Okay. All right, the last problem that I want to look at is also on page 416, and it's problem E. So a pebble is thrown into the air from ground level with an initial velocity of 20 feet per second. The height of the pebble h at any given time t can be described by the equation h equals negative 16t squared plus 20t. So h is the height, that's how high it is, and that's going to be equal to negative 16t squared, okay, where t is the amount of time that the pebble has been since it was thrown, okay, plus 20t. So where did this equation come from? You see this over and over again. So the 20t, notice it's thrown with an initial velocity of 20, so that's the initial velocity, and then the negative 16t squared, that's gravity pulling it down. So this was thrown up, and gravity's working against it, pulling it down. Okay. And so you'll commonly see the motion of any kind of projectile described in a simple. So you're always going to have a negative 16t squared. The number in front of this will vary, and there sometimes can be a constant as well if it's starts off the ground and it's not on the ground initially. Okay, but you know, that's where that equation comes from, why you see that same thing over and over and over again. All right. So we need to find the time at which the height of the pebble is 4 feet. Okay, so that means the height here, h, when will that be 4? So we would put the number 4 in for h and then solve for the amount of time t that would be required for it to be at a height of 4. Okay. So let's see, we had 4 equals negative 16t squared plus 20t. Okay. We're going to solve by completing the square. The first thing we need to do is make sure that the leading coefficient is 1. Right now it's negative 16. So we need to divide everything by negative 16. Okay, so we have negative 1/4 equals t squared plus, I guess I should have been in minus. Okay, let's see, 4 goes into there 5, 4 goes in there 4, so that's 5/4 t. Okay. All right, and now now we need to make sure that all of the constants are on one side and the variables are on the other. We're kind of used to having them on the other side, so I'm going to switch them. So we'll have the t squared and then minus 5/4 t. I'll leave myself a little room, and then I have the negative 1/4 on the other side. All right, so we'll just do it so that the variables are on the left and the constants on the right. All right, and now I have to add 1/2 of the coefficient of, in this case, t. So 1/2 of negative 5/4 is negative 5/8. So I'm going to add negative 5/8 squared to both sides. Alright, now this side is easy to factor now. T, and then whatever I wrote in parentheses, minus 5/8 squared. And on this side, let's see, so when I square negative 5/8, I'm going to get 25/64. So let's rewrite this as 64. That's negative 16/64. Okay. So let's see, that's 9/64 is t minus 5/8 squared. So now I will take the square root of both sides. So I'll get t minus 5/8. I'm going to get plus or minus, and the square root of 9/64 is 3/8. And then finally I'm going to write and solve two equations. So I have t minus 5/8 is positive 3/8, and I have t minus 5/8 is negative 3/8. So if I add 5/8 to both sides, I'll get t is 8/8 or 1. And if I add 5/8 to both sides, I'll get t equals 2/8 or 1/4 or 0.25, however you want to write that. Okay, so at 1 second and at 1/4 of a second are the times when the height of the pebble will be 4 feet off the ground. Okay, so that is the technique of completing the square.